Because the human body loses so much of its energy to thermal energy, right? That is the primary way that we lose energy, that we're inefficient, is that we put out a lot of heat to the surrounding environment. It's very important to understand how we measure that energy. And so in this section, we're going to look at both temperature and heat. First, let's look at the three different temperature scales with which we can measure. You need to be familiar with each of these. Those include the one that you're probably most familiar with, which is Fahrenheit. It's a good German word. It means to drive heat. Fahrenheit, Celsius, and then also Kelvin. So you've probably heard of the first of these two. You may not have heard of the third. However, the third is probably the most important because that is, yes, you guessed it, the SI unit for temperature. Um, Need to know the various freezing and boiling points of water. Those are important. And I want you to know them for both Fahrenheit and Celsius. So for water, the freezing point is 32 degrees. We don't see that very often in South Louisiana. The boiling point is 212 degrees Fahrenheit. For Celsius, these are much easier, and most of Europe uses the Celsius measurements for temperature are going to be 0 degrees Celsius, and then the boiling point is 100 degrees Celsius. So when we look at how we set up these temperature scales, these are based on these boiling and freezing points of water. What we do is we look at our thermometer and we say, okay, when we put this thermometer in boiling water, this is what it reads. And if I'm trying to define the Celsius scale, I'm going to print a 100 on that thermometer. And if I'm doing my Fahrenheit scale, I'll print a 212. So these are just numbers that we decided upon. We say that this is our boiling point of water, and when I put this thermometer into boiling water, that's what I'm going to print on the thermometer, 100 or 212. By the way, you probably don't see these very often, but this is a mercury thermometer, or it can have alcohol in it. It has a bulb down here. When it heats up, this cylinder moves up based on the temperature, and it'll move down. It's not something we see very often anymore. Now, the freezing point of water, if I were to put this in frozen water, or the temperature at which water freezes, I would see that on the Celsius scale, I would just print a 0 on that. And here on the freezing point, I would print 32 degrees Fahrenheit. So now I have 100 degrees in the Celsius scale from freezing to boiling, and I have 100, what's that? 180 degrees from 32 to 212. So I have 180 degrees here, and I just have 100 degrees here. So which is bigger then, a Celsius or a Fahrenheit degree? Well, I only have 100 degrees here, but I have almost twice the number of degrees here because I have 180 degrees. So the Celsius degree is a bigger measurement of temperature. A change in 1 degree Celsius is bigger than a change in 1 degree Fahrenheit. I do want you to be familiar with how to convert between these two scales. I'm not going to make you do that on the test or quiz. Your book does go into this, although I do want you to know a few sort of, you know, familiar or common temperatures in the Celsius and in the Celsius scale. So these are the formulae for converting. Oops. If I have a Celsius degree and I want to convert it into Fahrenheit, I say 9/5 of whatever that Celsius temperature is plus 32. So for example, if my TC is equal to 37 degrees Celsius, then that would be 9/5 times 37 degrees Celsius. Some of you might know where I'm headed with this, by the way, if you know what 37 degrees Celsius is, plus 32, that's equal to 98 degrees Fahrenheit. So that's one of the first temperatures that I want you to know, that body temperature for a normal human being is 37 degrees Celsius, or 98 degrees Fahrenheit, but I think you all know that. And then let's say that my Fahrenheit temperature is 70 degrees, which is a typical room temperature. So that's the other temperature that I want you to know, is what is the typical room temperature. Then the Celsius temperature is going to be 5 ninths times the Fahrenheit temperature minus 32. 5 ninths times 70 minus 32. and that's going to equal to about 21 degrees Celsius. And so room temperature is about 20 degrees Celsius. If you have a temperature of 30 degrees Celsius, that would be like a really hot Louisiana day. Okay, so these are a couple of standard temperatures, our familiar temperatures that I want you to know. And 70 degrees Fahrenheit, which is 20 degrees Celsius, our room temperature, our 37 degrees Fahrenheit, which is 98 degrees Fahrenheit. Excuse me, 37 degrees Celsius, which is 98 degrees Fahrenheit. The Kelvin scale is based on a completely different thing. It's based on absolute zero. Here's my mercury thermometer and the triple point of water. So absolute zero, they put this thermometer and they say, all right, this is the 0 Kelvin mark, and the 0 Kelvin mark is the point at which all motions cease. So because when you have a material that's made up of atoms, those atoms are always oscillating, vibrating around. But when you reach absolute zero, all motion ceases, even the motion of those atoms. It's a theoretical temperature. We've never reached it. We get really close. That superfluid video that I showed you with the liquid helium, that's really close to absolute zero, and we can in the lab get down to nano kelvins, which is just a 10 to the minus ninth of 1 Kelvin, so really close to absolute zero. But strange things begin to happen, like with the liquid helium reaches a zero viscosity and it begins to move through walls. All right, so Kelvin scale is based on this absolute zero. It's also based on the triple point of water. The triple point of water is a particular temperature and pressure where water exists in all three phases. It exists as a vapor, as a liquid, and as a solid. And so we have this Kelvin scale where we have 0 Kelvin is absolute zero, and 100, I'm sorry, not 100, and 273 Kelvin is the triple point of water. Okay, so the Kelvin degree is the same size as the Celsius degree. In fact, we don't really say Kelvin degree. That's not really grammatically correct. We just say the Kelvin. I don't know why that is, but that's what we do. Okay, so those are the different temperature scales. You need to know what they are. You need to know those basic temperatures, and you need to know what they're based on. All right, good stuff.